As I mentioned earlier, we haven't heard too much yet today about the kind of carbon thing. We have carbon targets. We must continue to aim to minimise carbon emissions. Quite often, carbon and costs go together, so they're not necessarily conflicting factors. But there's been a lot of work done recently by TRL and others on developing tools to calculate the carbon, the greenhouse gas emissions from different types of road material. And there's one there we've done recently for the Highways Agency, the Minerals Products Association and the Refined Bitumen Association on asphalt surfaces. Again, you've got the issue about the lowest initial carbon is not necessarily the same, it's going to provide the best whole carbon solution, and surface dressing is the example that if you surface dress the road, then yes, it's good for carbon, it's good for costs, but you may end up doing it in 3 or 4 years again. The third of my 5 factors is journey time reliability. Now, we know network operators want to minimise disruption to the drivers, but from a purely maintenance point of view, there are many benefits in actually closing the road and doing the maintenance in one hit. They include things like the actual quality of the maintenance and the working methods. Doing things like the Sharland paving there in the bottom slide can actually reduce the number of longitudinal joints, which makes it a more durable pavement. But there are a lot of other factors really, including things like road worker safety, very important things. But that has to be balanced against the journey time reliability and the impact on the road users. Conservation of resources, premium aggregates and so on have cost implications. Can we use more recycling in our maintenance methods, and can we cut down waste as well? So that's a very, very strong driver. We've done a lot of work with the Highways Agency, local authorities and many of the contractors to continue to develop the techniques that use more of what's there already and cut waste. And those techniques often reduce carbon as well. And then finally, the climate change resilience. When deciding what type of maintenance to do, you need to be very aware of the vulnerability of a particular location to extreme events such as flooding and so on. And the drive to give practical advice to engineers in this area is very strong. So there's 5 of the factors that come into the decision making, and what I'm going to do now is look at a few maintenance options and see how they stack up against those decision making criteria. Some of these maintenance options are quite well established, and some of them are actually a lot newer and really at the development stage, but we think are very promising. The first one here is ex situ cold recycling, so again the drive to get more recycled materials. This stacks up pretty well from the cost and carbon point of view. An example would be a scheme that was done recently, we did as a case study, a 7-kilometre stretch on the A38 in Devon. Using this methodology, saved 70,000 tonnes of primary aggregate, 19,000 tonnes less waste going to disposal. And on the cost front, 300k was saved out of a total scheme budget of 8 million. And the carbon estimates for the amount of carbon usage was about a 55% saving. So this one is pretty good on a lot of those factors, that sort of technique. Doesn't necessarily do a lot on the climate change resilience, but the others it stacks up very well. Moving to a different and a newer type of recycling, the tendency is using recycled materials to put them deeper into the pavement structure, but more work is being done now on recycling into the surface course and really making the best value of the premium aggregates into the surface course. It's basically kind of cost neutral because you've got less material coming in, but you've got a bit more processing to actually do this recycling. Better on the carbon front and better on the resources front, but probably neutral on the others. Let me move on now to the newer area of durable surfaces and a couple of projects we've been involved in. One is a new performance-based surface course specification for Transport Scotland, which has used skid resistance as the acceptance measure. What this has allowed to do by not focusing so much on surface texture but on skid resistance, it's allowed the compilation of a much more durable surface. We've done another project recently, again for HA, MPA and RBA, looking at durable surfaces which use smaller aggregate sizes, which again focus more on the skid resistance and sacrifice some of the texture. This allows much more durable surface. Now, this one's interesting because the initial costs on this one look like they're a bit higher, but the whole life costing and the benefits of these durable surfaces is absolutely clear. So there's one of the trade-offs then about when you do this. It's a similar story on the carbon, a bit more initial carbon, but whole life carbon is much more compelling. Journey time reliability better because you're maintaining less often, you have to go back to it less often, better on resources, and it is more resilient to extreme weather events because you've got a better durability. Then my final example is something that's more in the development stage, which is the high-performance thin surfacing systems. There's some European collaboration going on in this area. This is a very exciting area with looking at both bitumen and cementitious materials, and looking at very alternative binders and things like fine steel fibres in the cement, which allow much thinner layers, so maybe as little as 8 millimetre thickness on these layers. Basically, what they mean is a much faster lay, much less material. The trials are now progressing to a more advanced stage to see if these are feasible. So we don't know yet how the initial costs are going to stack up. Clearly, less material is going to be needed, but it's what sort of material and how much processing. So the initial cost carbon is not certain. Whole life cost carbon definitely better because of the durability of the surfaces. So let me just pull those three bits together now and say, well, we are making some major advances in determining condition. We clearly need to look after these very valuable assets as much as possible. The focus on condition monitoring is the accuracy of data, collecting more data more cheaply and allowing that to feed into better decision making. But the decision making is always a trade-off between all these things. But really, the current financial constraints, we've heard it already, don't go too short-term in the thinking because the long-term disbenefits of that are very clear. But now for a bit of future visioning. Now, what I'm going to talk about now is not separate to what I've talked about. It's actually about bringing all these ideas together into a an integrated view of what the future roads will look like. And this is not just about new roads, it's about retrofitting. So when we do maintenance on an existing road, building in some of this future-proofing. This is a concept that's being developed by a European group of which TRL is a member and a leader in this project. And it's making, say, one solution into this thing we call the forever open road, a road that needs no maintenance. There's got three components to it. It's a road that's adaptable to changes in technology, to changes in demand, those sort of aspects. It's a road that's got a lot of automation in it, a road that can communicate with road operators, with vehicles and with drivers. And it's a resilient road that's resilient to climate change and more extreme weather. And just to finish, I've got a little bit of a schematic here, bringing in some of the concepts that I've talked about, and some quite futuristic ones, by the way, as well. But as I say, it's about integrating this thinking into a vision for how it will be in the future. That doesn't mean it's going to be massively expensive. It's not an expensive vision. It's about getting best value by integrating ideas. So, on the road construction itself, then, for components, new roads and new components, more prefabrication off-site. Talked about carbon-free, and I've talked about the importance of recycled materials. Thinking much more, both in new build and maintenance, about the drainage requirements and more built-in flood resistance. Thinking about the intelligent road then, and the adaptable road, having more built-in bolt-on infrastructure. The road pavement and the materials itself, this one is a bit futuristic, but instant crack repair, looking at new materials that can do this. Going back to the sensors and having the pavement that can talk to the operators and so on, building those in, and the road that measures its own condition. And then the intelligent road that talks to the vehicle and talks to the driver, systems like lane and vehicle direction information and inbuilt electronic vehicle guidance systems. And then thinking about the road actually as an energy storage medium. So things like winter maintenance, if we can store energy from the summer heat and use that energy to help maintain the road in the winter and protect against snow and ice, then that's a good thing as well. And then the kind of whole carbon capture thing around by the planting. So this is some of the stuff in the Forever Open Road. We think this is a really valuable concept to help pin the ideas, all the individual ideas on, and help us go in a good direction. So that's the end of my presentation. I hope that's been interesting. I look forward to questions.